Graphing rational expressions, or rational functions, sorry. This right here is pretty much to just overview how to find the asymptotes, because that's what a lot of people are having trouble with, or I actually used the definition and didn't give you any hints on how to do that. So there are two types of asymptotes that we want to focus on. There are the vertical asymptotes, and then there are the horizontal asymptotes. So those are the two types that we want to focus. We want to make sure we understand vertical and then horizontal. Okay, we have three examples over here, horizontal. You may want to write this down in your notes, or at the very least, watch this video a couple of times just to make sure you understand it. All right, so the vertical asymptotes. The vertical asymptotes are easy. The first thing I want to say is this, is you want to reduce the fraction. Okay, reduce the fraction. If it can be reduced, it doesn't mean you can always reduce it, but if it can be, you need to. So on this problem here, on the first one, 3x over x minus 2, you can't reduce it. So you don't have to worry about reduction on this one. On the second one, however, you'll notice that you have x squared minus 2x plus 1, which can factor to x minus 1 times x minus 1 over x plus 1, x minus 1. So in this scenario, the first thing you're going to want to do is reduce the fraction. So you'll notice that the x minus 1's cancel each other out, and the result is x minus 1 over x plus 1. Now this canceling, you need to make sure you state. So I'm going to put a stipulation on the x. X cannot equal 1. So x is not allowed to equal 1 because x minus 1 was in the denominator. Now we can find the asymptote for this guy, so we want to reduce the fraction. Problem number 3, you can't reduce it, but you can factor it. So it may be helpful or beneficial to you to factor this guy out over here by taking out the GCF. So we have x times x minus 4. Now, the first thing for vertical asymptotes is to reduce the fraction. After that, what you want to look at is the denominator of the function, which we call d of x. When that guy equals 0, that's when you have your vertical asymptotes. So for the problem up over here, problem number 1, the vertical asymptote is going to occur when x minus 2 is equal to 0. And that's going to be x equals 2. So that's going to be your first vertical asymptote. On problem number 3, your vertical asymptote is going to be the denominator is going to be equal to 0. So we're going to say x plus 1 equals 0. Notice we don't want to do it up here. If you did it up here before you reduced it, you would include 1 as one of your asymptotes, which it is not. So now we're going to say x equals negative 1. That's a vertical asymptote. And then our final problem, we're going to say x times x minus 4 is equal to 0, which means we have two vertical asymptotes. We have x equals 0 and x minus 4 is going to equal 0. So our two asymptotes are going to be x equals 0 and x equals 4. That's how we find our vertical asymptotes. So first thing you're going to do is reduce the fraction, and then set the denominator equal to 0, and that identifies your vertical asymptotes. Now, later we will talk about what this means. Right now, focus on vertical asymptotes. Second, the horizontal asymptotes. This guy is a little wonky, so there's some rules that we need to make sure we pay attention to. So, number 1, the first rule, okay? All of the rules have to do with the degree of the polynomial. So we're going to say the degree of the numerator, and the degree of the denominator. So the degree of the top and the degree of the bottom. When the degrees are equal, so if the degree of the top is equal to the degree of the bottom, what you want to do is you want to take the leading coefficient. So think of it this way. n of x is equal to some polynomial a sub n, x sub n. You guys remember that whole nonsense, right? That gigantic polynomial that was, most of you didn't remember what it meant. But the idea here is that if you take the lead coefficient of a sub n, of nx, and you take the lead coefficient of the denominator, which I'm going to call b of n, so b of n, where you have a polynomial. Now, why are the n's the same? Because I said the degrees are the same, plus b sub 0. The asymptote, okay, so the horizontal asymptote is going to be y is equal to the lead coefficient, sorry, that's not the coefficient of the lead coefficient of the numerator over the lead coefficient of the denominator. So if I was taking a look at these problems up here, you'll notice that in our first scenario, we have a degree of 1 on the top and then a degree of 1 on the bottom. So the degrees match. What that means is that our y asymptote, our horizontal asymptote, is going to be the lead coefficient divided by the lead coefficient. Now this only works when the numerator and the denominator have the same degree. So my answer for my horizontal asymptote is going to be y is equal to 3. Okay, that's the first one. Now, the second one, if the denominator, actually let me erase this right here. So if you guys have this not written down, you may want to go back and take a look at it. The second thing we want to take a look at is that if you're talking about the degree again, so if the degree of the numerator, is larger than the degree of the denominator, what that tells me is that there are no horizontal asymptotes. No horizontal asymptotes. Now in the problems above, none of them had the degree on the top bigger than the degree on the bottom. So the idea of this one is that when the degree of the top, so let's say the degree of the top was 5, right? So if you had something like x to the power of 5 over something on the bottom, say x to the power of 3 minus 2, this thing here has no horizontal asymptotes. Okay, so that's the second rule you need to remember. And then finally, the last rule. The last rule has to do when the degree of the top is smaller than the degree of the bottom. So when the degree of the top and the degree of the bottom are smaller, the degree of the top is smaller than the degree on the bottom, the horizontal asymptote is automatically 0. So when the degree of the bottom is smaller than the degree of the top, we're going to say that the horizontal asymptote is y is equal to 0. So if you take a look at our second example, or third example, sorry, you'll notice that the degree of the top is 0, the degree of the bottom is 2. This tells me that my horizontal asymptote is going to be y is equal to 0. Okay? All right, so one more time. When the degree of the top, the numerator, is larger than the denominator, there's no h asymptote. Okay? No h asymptote. When the degree of the top is equal to the degree of the denominator, then what we have here is that the asymptote y is going to equal the top's lead coefficient over the bottom's lead coefficient. And then finally, when the degree of the top is smaller than the degree of the bottom, we know that our horizontal asymptote is going to be 0. Those are the 3 rules that I need you guys to remember for horizontal asymptotes. So, to cap it one more time, vertical asymptotes, reduce the fraction, set the denominator equal to 0. Horizontal asymptotes, you have to check the degrees of the tops and the bottoms, and then follow these rules, 1, 2, and 3. Thank you. Take a look at the assignment, or take a look at the next video to learn how to graph it based upon these asymptotes.